The search for life in the universe can be likened to looking for a place to plant a tree. You're always on the lookout for the right spot. Water is essential for life, so potentially habitable planets must have liquid water. However, several conditions must align for this to happen. The planet must be in the habitable zone of its star, where temperatures and atmospheric pressures are suitable for simple life forms to evolve. If a planet is too close to its star, water will evaporate, like what happened on Venus, which is too hot for life, despite its size and mass being similar to Earth. On the other hand, if the planet is too far from its star, it will be too cold for liquid water, with water existing only as ice. Planets like Neptune fall into this category, where water may exist deep below the surface in liquid form. The planet must also be solid and have an atmosphere that can shield it from harmful solar radiation, enabling life to breathe. In our galaxy, there are countless stars, and many of them could host exoplanets, planets orbiting other stars. Some of these planets might be in the habitable zone and have conditions ideal for life to develop. From over 4,500 known exoplanets, scientists have found 24 that could potentially be superhabitable, meaning they may be even more suited for life than Earth. These superhabitable planets would likely be twice as massive as Earth and 1.3 times larger. This larger size leads to stronger gravity and a denser, warmer atmosphere, which could encourage a greater diversity of life. The stars around these planets should ideally be smaller than the Sun, with a lifespan of 15 to 30 billion years, allowing ample time for life to evolve. Stars like these are typically dwarf stars, although smaller and less luminous than the Sun, live much longer, 20 to 70 billion years. Superhabitable planets would likely be warmer than Earth, with an average temperature about 8 degrees higher. These planets would also have more water in the form of clouds, liquid water, and humidity, creating conditions favorable for biodiversity. Similar to Earth's tropical forests, these 24 candidates for superhabitable planets are all located over 100 light-years away. But with new telescope technologies, we may soon be able to confirm if they could support life. The closest exoplanet to us is Proxima Centauri b, which orbits the red dwarf Proxima Centauri, the closest star to the Sun. At only 4.2 light-years away, its size and mass are similar to Earth's, but it likely has an icy structure like Neptune. Despite being the closest star system, Proxima Centauri is too dim to be seen with the naked eye. While these planets are in their star's habitable zone and could potentially support life, the distance between us and these exoplanets is a major challenge. Our modern rockets travel only 5 times the speed of sound, meaning it would take over 100,000 years to reach Proxima Centauri. To solve this, scientists are considering the possibility of warp drives, technology that could manipulate space and time. However, powering such a spacecraft would require an immense amount of energy, close to what Jupiter generates. New calculations from NASA's Jet Propulsion Lab suggest, in the future, NASA plans to launch its first interstellar mission by 2069 to explore potentially habitable planets outside of our solar system. While the technology to travel to distant stars is still developing, there is hope that one day we will be able to colonize these exoplanets and potentially find new homes for humanity.